We'll look at kind of overall picture, and the way I like to forecast is starting with the big picture, kind of the whole atmospheric weather. I know sometimes when people are introduced to weather, it's more at the smaller scale, like, hey, if it's south, I'm going to the south side. If it's north, and there's so much more to the weather than that. There's so many layers. So I like to look at it literally from the top down. So that's what I'm going to start. I'm going to go through several links. I think I can make this available. Can I make this sheet available? So
if you want to, you can, for sure.
Sure. So if you want to go through the links, and if you have questions, just let me know. I'll talk for about an hour and then open it up to questions. So there are no dumb questions. So feel free to reach out, and hope to fly with you all this summer. Cool. So I like to forecast, and they teach us at the Weather Service as well. And when we come in fresh from school, they're like, all right, forget everything you learned in school. We're not going to deal with any modeling or any specific formulas, but we are going to look at forecasting from a top-down approach. So whether we're ridge soaring, going XC, staying local, whatever the case is, you want to have a good idea of the 3 dimensions of weather, from the surface up to cloud base, basically, and even beyond. So key to a safe, fun, long or short flight is having a good idea of the whole picture, the whole air that you'll be flying in, vertically and horizontally. If you want to fly 200 miles, you better forecast for all 200 miles. Forecast for whatever the corridor is. When I started flying hang gliders in '89, and I didn't become a meteorologist until 2003. So I had all of that experience under me. And we would be flying close to 200 miles, so we would forecast for that. But at the time, we had WX brief. We'd call in and get an interpolation of the forecast. Now the modeling is so much better, and I love what I've seen in the club as a whole, because a lot of times when I came here, people were like, yeah, is it south? We'll go to the south side. If it's north, we'll go to the north side. And now a lot more people are looking at the whole picture. So I'm really super psyched about that, and I figure for those that haven't or don't know, that maybe this will give you an intro, kind of what your interest, and maybe at some point you'll be looking at the whole 3 dimensions. So I like to start out with the big picture, which is only 2 links, and we'll get down, then we go to the observations, and then we go to the answers. So the first big picture, we look at the global models. There's a couple of free websites, if I can find my little pointer.
It's so zoomed in.
Sorry.
You might have trouble.
Okay. Where is the pointer?
See it right here.
Oh gosh, that's tiny.
I know. So are you trying to click on this?
I am trying to click on that. I may have you just come up for every time I have to click on something.
Maybe I'll just pull up a chair.
Okay, that sounds good.
And then zoom in.
Yep. So, is it possible? Okay, I'll just talk through it.
Why don't I just give you some tech support up here?
Oh, you touched it.
Oh!
No! Nate!
All right, while they're talking. So there's 2 essential internet pages, Tropical Tidbits and Pivotal Weather. So I've got links here for Tropical Tidbits. What the default page pulls up is one of the answers page. It shows precipitation. But I like to go back to and look at the current conditions first. So I go to the ensemble tab at the top. How do I get this centered? Just move it over. And is that a touch screen or no? Okay, I guess you'll have to do my, okay. EPS. So the top selection in the ensemble model is the European model. And what an ensemble is, it's basically, just like it sounds, a collection of the European models, like lots of different models, different parameters, different weights. So an ensemble is kind of like the average of those models. And the European has the most computing power, which is why it's proprietary, it costs money. So as of right now, XC Skies doesn't carry European stuff, ECMA. But the Tropical Tidbits is the free website that does, and Pivotal Weather's the other website that has free stuff for EC. And I like to use the EPS, that's the ensemble model of the European, for long range. So basically, if you go to Right now it says forecast hour 12. If you back, let's see, if we go back on the runtime, or yeah, click the little arrows at the top. Okay, you see where it says analysis up at the top. So go forward on the, yeah, until we're at our last analysis. Okay, one back. Keep going back. One more. There it is. Okay. Oh, keep going forward. There it is. Okay, so you want to get to an analysis. The very last analysis before it moves into forecast is a current picture of what's going on. There's a lot here, but I'll really simplify it because it can be broken down into just a couple of simple aspects. You want to check your date. Always check your date on the forecast, whether it's the soaring forecast or anything you're looking at, especially like if you're looking at UT7 for Meso-West and it's like, oh my gosh, it's still south. It could be yesterday's data. So make sure you're checking the date. So analysis is what's currently happening. The major points we see are low pressure systems. That's going to be in your cool colors, basically the blues, and the more intense blue, the lower the pressure. And then your highs are up here. So we've got it valid at 12Z, Zulu time. Anybody know how we are here in relation to Zulu time? Right, in the summertime, which is when we usually soar and we're looking at these products, we're 6 hours behind. So just think Zulu time is in England, so just think of like if you go from New York to here, we're behind the New York time. So we're 6 hours behind in the summertime. So if you see 12Z, that's 6 a.m. So that's a picture of the upper atmosphere. Now we see EPS 500 millibars. Do I have a pointer by chance? Okay, so I can't jump, so you'll have to just follow my finger. 500 millibars. Anybody know approximately what altitude that is?
10,000? 12,000? 18,000?
18,000. 18,000 feet. It's approximately 18,000 feet. So that's our lid. You know, we can't officially fly above 18 unless we have special clearance. So this is what's happening at the very top of the atmosphere. And if top of lift for the day is only 12 or 13, we're not really going to feel those winds, but we're generally impacted by the larger system. So this is the biggest picture that you'll need to look at. So you've got lows here, and the winds follow these contours. So around a low always rotates counterclockwise. So those are the main two things you have to remember, is the low is counterclockwise, so the winds are going around in this direction in the upper atmosphere at 18,000 feet. And the highs is clockwise. Just think of like saying hi to somebody. It's clockwise. So I'm going to try and do the same direction as you're looking. So the winds will come around here. So that's one important thing to remember, the highs versus the lows, direction of the wind. The other thing is when these are called isobars, they're same barometric pressure. When they are closer to each other, that is windier. So you're going to have more wind down here, and generally this is where you will see more wind in a low, kind of the lower right-hand corner. That's more windy. This is less windy up here. So those are the two things that you can take away from this. This is the current picture. So let's see. As of today, at 6 a.m., we are under the influence of a low. So why are we getting these afternoon thunderstorms? Look at the rotation. Look at where the low is. It's pulling up moisture from the ocean, the Baja area, and bringing it right into Utah. So that's kind of the picture that you can start to develop when you just see this snapshot. If I wanted to find some high pressure, if I was a jet setter and I could go anywhere, I'd probably fly at the interface of these two systems. Maybe they're having a really good day up in Wisconsin or even Indiana or something. So if you can jet set, go for it. All right, so that's like the main big picture for that. I'm gonna get back to my other. So if you want to write down questions or something, it'd probably be better to do them all at the end. But if it's something burning, I can do it now.
Sure, why not?
Go for it.
Are you using 18,000 feet as your reference because that's what's most relevant to us as pilots, or because that's the altitude that gives you the best indication of what's going on?
That is the best indication of what's going on big picture. The other altitude to look at, anybody know?
Surface.
Next is 700 millibars. 700, so usually they have modeling at, and there's, if you go through this page, you'll find some diagrams that are 700 millibar, but 18,000 is the 500 millibar. 700 millibar is the top of the Wasatch. So that's the next one that we want to look at, and that's about 10,000 feet. So generally you'll see similar patterns. You're not going to have like a high here and then a low here necessarily. It's generally not going to be that different. So that big picture 500 millibars will give you the best kind of snapshot. Okay, so we talked about clicking the ensemble, EPS. The GEFS is the GFS ensemble model. That's the basically North America. And that's good for as you get closer to your flying day, maybe 3 days out. The blue is the trough, orange is the ridge, upper level circulation around the high is clockwise, hello, around the low is counterclockwise. Lows are often accompanied by active weather. Just think this is what we have right now. You saw the rotation, it's pulling up all that moisture. Okay, so the next big picture thing is the forecast discussion. Don't be afraid, there's a lot of words, but after we look at the big picture, then we can see how that's translated into words by the National Weather Service. So this product is produced at least twice a day, and sometimes it's updated. And can we get that bigger? Nice. So they always give a synopsis. So again, check your date. Make sure you're dealing with today. They update that in the afternoon, usually about 4 a.m. and 4 p.m. And it does say about 4 p.m. today, June 1st. So it always starts out with a synopsis, the big picture of the big picture. And again, the National Weather Service in Salt Lake forecasts for basically the whole state. So there's a lot of area to cover. So whether you're going down south or if you're basically staying around the state, this discussion will usually apply to you. Synopsis for today: unsettled weather, shocker, will remain in place through the end of the week as an upper level low encroaches on the region from the west. What's an upper level low? I forgot what an upper level low is. Well, we have this handy dandy turn dictionary on in the top. That pointer does not look that big on the screen, by the way. And there you go. It's all lit up in blue, so you can go and mouse over and it will give you the definition. So what did you mouse over there?
Upper level low, I hope. That's what I was going for.
Nope. Try a lower one. There it is, right there. Okay, so what is an upper level low? A region of low pressure marked as an L on a weather map. A low center is usually accompanied by precipitation, extensive cloudiness, and moderate winds. Cyclone is another name for this type of rotation, but not all low pressures are going to give us a cyclone, so don't worry about it. But any of the terms that you need refreshers on or you want to know about, you just mouse over. But you do have to turn the dictionary on in order to see those. Okay, so again, let's just keep talking through it a little bit. So the short term, they always give a short term, which is a couple days out. Today's Thursday, so it goes through Saturday morning. And then there's a long term below that. And then there's an aviation discussion where they talk about the 10 different airports across the state that they forecast for. Let's go back up to the short term. So short term, so they give afternoon satellite and H5, which is the 500 millibar. If they say H7, that's the 700 millibar. Satellite analysis, current conditions, versus the forecast, which is in the future. To pick two notable features about the Great Basin region, which is this Four Corners area. An upper low gradually filling whilst lifting northeast across the Four Corners region. So already we can get a picture. We've got a low pressure system that's lifting to the northeast. So this circulation, which is this direction, right, is lifting up across the state to here. So those winds, whatever's in rotation, is going to be going across the state like that. So you can already get an idea of what's going to happen the next couple days, you know. And if it doesn't happen, maybe the low didn't move as fast, or it might move faster. So understanding the bigger picture gives you an idea of what might happen, but also what might not happen if big systems change, or they go. A lot of times they will go slower, or they'll go faster. But if you get a general idea of where it's moving, then it helps paint another picture for you. Okay, and then just a little more of this. An upstream vort lobe. I'm surprised vort's not. Let's mouse over upstream. Okay, so upstream, I mean, it's what it sounds like. It's where it's coming from. Vort lobe is vorticity. Vorticity is the spinning action of the air. That's what we need to produce rising air. So I'm surprised they didn't have that in the dictionary. But anyway, so they're talking about instability. So you can read about what's happening there. I know it's a little daunting. It's a lot of words. But the more you read it, the more you'll understand. And then again, ask your buddies questions who read this a lot. And if all else fails, text me. All right, so that's the discussion. We're going to go on from there. Back to the script. Okay, so those are basically 2 links for the big picture. And now we can start to go into observations. First observation I like to look at is our very own soaring forecast from the National Weather Service. So we launch a balloon, a weather balloon, twice a day. In the summer, it's at 5 a.m. and 5 p.m. So the 5 a.m. balloon goes up, it has a little radio sonde, and it gathers all kinds of atmospheric information: temperature, wind direction, wind strength, pressure, humidity, things like that. And it's tracked all the way up to about 100,000 feet, so right at the edge of space before the balloon pops. And it transmits all that data back down to us. So it's really interesting stuff. We usually have a product that comes out of that that's pretty detailed, that not only shows you the actual winds that were present along its path in the morning, but it also interpolates and it gives you such parameters like top of lift and thermal strength, overdevelopment potential. It's usually pretty detailed, but that, I have to say, that product has been broken for a little while. We're working with the Boulder, Colorado office to get that back online. So in the meantime, we've got, I think I have it up. Yeah, let's click on that. And make it bigger if you can for me. Thank you. So we do have some information directly from the launches in the morning. Again, the balloon pops about 6:30 in the morning, so you have an hour and a half of flight time. Generally, it's a south flow in the morning, so it kind of goes up a little bit toward the north, and it gets all of that vertical information from the surface up to 100,000 feet. So these are the actual winds you're seeing. So if you're going to go fly the south side, this is a really handy thing. It's generally going to be, if it's south, it's going to be a little stronger at the point. But you want to see what these winds are above the point, because if it's cranking, those winds are going to mix down to the surface when everything starts heating up. In the summer, that may be as early as 10 o'clock or 9:30. Question?
This is launched from the Salt Lake Airport, right?
Yes. Mm-hmm. Yep. So it's maybe a little bit north of the flying area, but again, it's capturing the big picture information, the upper level winds. So these are actual winds, observed winds. Any models that you look at, if you're comparing them to the observed winds and they're different, you can weight that model accordingly. If your HER winds are completely different than what you're seeing from actual observed winds, you're not going to give that a lot of credit, at least for the early morning. Okay, so some other parameters that we do have for the summer are height of the -3. That is an instability index, and that will basically show you where your thermals are going to start slowing down. I can explain the temperature stuff later and what -3 means, but basically those thermals are going to start slowing down at 8,100 feet. If I want to go fly inspo, I might have an easy time getting up to 81, but then I'm going to need something a little stronger to bust through and get to the top of the lift, which is 18. So I'm probably going to need something a lot stronger to bust through that -3. So max temperature was forecast for 83, first usable lift. There's a pretty good discrepancy there. So, you know, it might be an early day. If there's like more than a 5-degree temperature, you can start going early in the morning. Again, this is more for thermic stuff. But if you're flying, say at the south side, it's forecast max temperature 83, and your first usable lift is maybe at 82. You can probably hang out at the south side for quite a while that day. It may not pick up very quickly, become turbulent very quickly. But if your first usable lift is quite a bit lower than the max temperature, things are going to start cracking early. So it's just kind of a heads up. When you're, especially in the summer, when you're soaring the south side, things could get pretty spicy early on. So that distance between the two temperatures is kind of good to be aware of. Okay, and then if you're thermaling out during the day, it's generally even a little more than that. This was arranged for sailplane pilots, and we have a better sink rate on a hang glider, and then an even better sink rate on a paraglider. So you see an average of 700 foot per minute. You could easily find areas over, or maybe 1,000 or over 1,000. So that's kind of the value of this. Anything from just current winds to some instability to when it's going to get spicy. So that's the first of the observations I check. And then of the 5 links, the next one is a couple of actual real-time visuals using the satellite. And again, I like to go back to the Tropical Tidbits because they have a good satellite. There's also a website called Windy. Some of you are familiar with it. That has a lot of these parameters, kind of your one-stop shop. So play with Windy. You can find satellites on there, get together. I haven't done any kind of Windy talk. I might at some point. I do more XC Skies, which is, I guess, more of the answers talk. But so this is available in these links. It's also available on Windy. So this shows you your water vapor. Water vapor is not clouds. It's the vapor that's in the air, and it has the potential to become clouds given the right conditions. So this is kind of where it's juicy in the upper atmosphere. And it's current model. So we're going all the way to 715 is where it stops. So this is very current. You can see some vapor coming in, you know, again, this low pressure system. And then you can kind of see a little bit of the wraparound flow. There's another low up in the top corner. Let's see, where do we see that? We saw that ridge over here in the Midwest, so you can see that kind of rotation up here. So it's kind of neat to just kind of look at that. And again, you can get an idea of the big picture. So let's go to the next link. So that's water vapor. We can also look at the current clouds. So very similar because it's late in the day, so that water vapor has been heated up and is producing these clouds. But you can see it's a little bit cloudy over Utah. This is a good one early in the morning. If you're not expecting any clouds and you open this up and you see a huge cloud deck, you're like, okay, things are not like I thought they were going to be. But it's like having a very big window to the sky. So these two products are really good. And let's go to the next one. Okay, and then the radar. You know, you definitely want to see if it's raining anywhere when you wake up because you can't see that out your window. So radars, this is the National Weather Service product. I recommend the My Radar app. It's free, and it has a composite radar of Salt Lake, Cedar City, and Grand Junction, and I think even Pocatello. So you can see water, or you can see the actual precipitation. It may not be reaching the ground, keep that in mind, but this is a good thing to check on. Even in cross-country flight, it's good to pull up that app in the air if you're thinking that it might be raining somewhere on course. My radar is a good one to pull up. So, okay, so we got some activity going on. And basically, let's see, do we have the legend? So The radar sends out beams, and anything it hits gets reflected back. If it's just, here's the 0 mark. So if it's in the little blues, there's a little bit of water vapor out there, a little bit of precipitation. The greens is more so. As you get into the yellows and reds, it's kind of like, it's like a stoplight. Hazard and then stop if you get the reds. So those are usually cells, especially in the summer, they often produce lightning. So you can see we've got cells happening in the northwest, and they're still, with the heat of the day, they're still being fed. So they're still happening. More stuff out in the desert. Not as much here. Sometimes you'll see these hanging over the mountains. They may be real, they may not. If they don't move, then you can, if they're blues and they don't move, you can kind of take them with a grain of salt because they're just like echo returns. But if you've got stuff out here and it's moving, bigger areas of precipitation showing, there's stuff going on for sure. Okay, so next observation. So that was observation 4, one more. Okay, so I did mention the, my radar is good. Radar scope has a little bit more, but it used to have lightning. My radar never used to have lightning, and the radar scope did, but now my radar has lightning, so I don't know that there's a need to pay for radar scope. And then the last thing we want to look at is the winds. So this is the National Weather Service page. Also, you can get the app. What's the app called? Anybody? The wind? Wind alert. Yeah. That's the free app. And that it doesn't show you as much detail as this one, but again, it's a quick app. It's one tap, and it's a good thing for you if you're flying cross country to check out, or it's really a good thing for your driver to check out, especially if there's any cells anywhere in the area and you want to know about an impending gust front. You can have your driver get on and see if there's any super strong winds in the area and get a good heads up. So, it's a little overwhelming. So you can zoom in and get more detail, but basically, for those who are new to looking at winds, the little barbs are at the end of the wind direction, just like an arrow. When you shoot an arrow, the little fluffy tail is in the back. So these winds are coming from the southeast in Tooele, and the bars, it's maybe hard to see it, but there's a little tiny barb that's going to be about 5 knots, and then kind of a healthy size barb, single barb, is going to be 10 knots. So you've got a big barb and a little barb there, which is how many knots? 15, very good. And then not a lot of wind going on right now. If there's outflow from rain or a thunderstorm, you'll often see gusts that are 20, 30, 40. So that's good to note or have your driver note. Let's see, we saw some activity up here on the radar, but I don't see any strong winds, so it's telling me there's not a lot of outflow. Any 20s here? Nope. So if you're at a computer, you can mouse over any one of these points. So the number in red is the gust. So you can just see the numbers straight out from here. There's a 20, 25, so it's 15 gusts to 25. So the reds will tell you what the gusts are. There's a gust to 34 up here, so there's some, that's telling me there's probably some outflow, or it's a bad, it might be a bad one. But you can zoom in to get more results. Question?
Yeah, what elevation are these winds at?
You can mouse over each site, and it will tell you when you mouse over. Help me with where the.
So tiny.
It is tiny, but so it'll give you the name of the site, and then your wind, all of your information. And here's the right up in the upper right is your altitude of that site. So whatever you're mousing over. And if you have a place that you fly a lot, you'll kind of get used to which sites to look at. Yes?
What's the source of this information?
So this is on the National Weather Service page, but it's a MesoWest site. And MesoWest is an area-wide network. I think it's a nationwide network that just incorporates UDOT and Weather Service and individual people's, like Campbell weather stations or some weather stations that actually talk to the page. So it's really like, this is just like a warehouse of everybody's information. So, you know, some of the private ones may not be QC'd, but when you hone in, there's a lot of observations. So you can kind of do your own QC. And if something is really like, that's blown 106, you know, and everything else is like 12, then, you know, it's probably a bad gauge. But yeah, you can hone in and get a lot of observations when you zoom in. And again, if there's certain sites you like to fly or a path that you're going to fly along, you can zoom in and just get used to kind of that area and where to look and what the elevations are. Okay, and I think that's the last of the observations. Oh yeah, and then if you want to see cameras, if you want to see real-time view, we have a couple of really good cameras. Let's go ahead and click on that. So there's a whole list of the different area cameras. So this is the default. It goes to Salt Lake and Utah Valleys. This Daybreak Southwest is actually our meteorologist in charge, the boss of the Weather Service. It's on his home in Daybreak, and it's looking southwest at the Ogres. So it's a really nice one to see that potential afternoon overdevelopment. These clouds start bubbling up. You know, they're bubbling up at 11 in the morning. You know, something's up. So that's a good one to look at. Olympus Cove, around the Mill Creek area, looking to the northwest. So that's a really good one to see incoming weather again for like the north side. Provo BYU is looking at Timpanogos, so good one to check if you want to go to Inspo. And then let's go to the Wasatch Range. So you can see cameras from the ski areas, and scroll down for me a little bit. So you're looking out at the valley from Alta. If you're going to fly up north, there's Cherry Peak. You don't want to go to the snowboard at the canyons. You'll fall off. And Evanston, Heber, if you want to fly out in that valley. All right, scroll up one more time. So if you want to see all the cameras that are available, you can go to all cameras and then just scroll through them and check them out for your area. They also include UDOT cameras, so there may be a lot looking at the roads, but sometimes it'll have roads and, oh, there's some clouds there. So they're pretty useful. Okay, so that is the end of our observations. So when I got to the Weather Service, my boss said, I was, looking at the forecast for the day and was looking at the precip and whatever, and he comes over and he's like, "You're just looking at the answers." And I'm like, "Yeah," because that's all I'd been doing for 15 years. He said, "Let's look at the big picture," and that's when he introduced me to the way we do things at the Weather Service. So the forecast is the answers. It's what we think or the model thinks is going to happen. But by looking at the big picture, what could happen. If this trough doesn't move through as fast as they say it's going to, it's not going to rain. You're telling me it's going to rain, but if it may not rain, because that trough, it all depends on the big picture. So you kind of take the answers with a grain of salt. They have more weight if you know what the big picture is. Does that make sense? Okay, cool. So first of the answers, we're going to go back to that 500 millibar, and I'll show you the 700 millibar too. So the default that pops up is the GFS, which is the Global Forecast System. It's the North American system. Again, good, maybe 3-4 days out or closer. And this is showing precipitation. So you've got your legend up here. 6-hour averaged precip rate, which means at the end of 6 hours, at the end of the 6-hour period, this is what you're forecasted to see. Let's go, okay, forecast valid at 0Z Friday, June 2nd. So what is the TOVA? What is the day and time for this forecast?
June 1st.
What time? 6 a.m. or p.m.? Huh? You're very close.
AM?
If it were 6 a.m., it would say 12Z. We are 6 hours behind what it says. So you're on the right track.
1.
Okay, who can help Tova? Lifeline. Anyone? Anyone?
Is it 6 p.m.?
Speak up. 6 p.m. Friday, or tonight, 6 p.m. Because this says it's midnight on Friday. So this is the trickiest one of all. Sorry, I didn't mean to pick on you. If I had a starburst, I'd throw you one. So 0Z starts a new day in England, but we're still 6 hours behind here. So as of 6 o'clock tonight, this is what's going on. This is basically the end of the 6-hour period of precip has accumulated this much in Utah. So you see northern Utah, the northeast Utah really got it. The mountain chain going up to Idaho, that's where the precip has been focused today. Let's move through the forecast. You can click on the arrow, one click at a time. And it's moving in 12Z, 18Z. It's moving in 6-hour increments. So I'd say generally for the afternoons, if you're looking at the 18Z, that's noon. And then the 0Z is 6 p.m. So those two, the 18 and 0, will give you a good look at what the forecast is from the GFS for that day. So we've got, let's back up a couple. Okay, stop. Let's go to 18Z. One more. Okay, so here's noon on Saturday. Little bit happening, but it looks like it's to the northeast. One more click. And this is by 6 p.m. on Saturday. There's some cells around, but not as bad as today, right? Looks like there's a little less precip. Let's move to 18 on Sunday. There it is. Okay. Concentrated in the north. So central Utah, southern Utah might be good to fly in. One more click. And that's the afternoon. So things might fire up along the mountains. So you kind of get an idea of what the GFS is forecasting for precip. So you can scroll out a whole week with this just to get an idea of what's going on. Okay, so then.
Updated twice a day, right? Still.
It might be more than that. Since the model is every 6 hours, it might be more than that. I don't know. I don't know how much, tropical. I think in our office it updates every 6 hours. So I don't know how the website relates to that, and I'm not sure how Uhgpga'S relates to that.
It's every 12 hours on Uhgpga'S.
Is it? Okay. Yeah. So this is, I think this might be more current. You can check it against it. So if we go to Ensemble, actually, we're going to go to global. So if you want to look at the 700 millibar at the top of the Wasatch, let's go down to the GFS. And if we go to lower dynamics, I think, and you see 700 wind there. 700. Yep, 700 Wharton wind. Vorticity, again, is the spinny. So that's the amount of instability, and we're looking for wind. So this gives you barbs. So it's more of the answer. And it's very spread out. So it's a rough picture. And then to hone in on it, that's when we go to Uhgpga'S, but that's next. So this just gives you a rough picture. And did anybody notice how fast the clouds are moving today? Did anybody look up and see or look at the soaring forecast?
I know.
It was pretty light. It was pretty light movement aloft. I didn't see much the clouds tracking many places. And when you get a light flow aloft like that, the precip can really linger. It can really hang out and stick around for a while. So it's good to note how fast those clouds are moving. Look at the shadows on the ground, that track that. Is it really moving to the east? Or some days you see a cloud building and you're like, that's moving to the west. That's weird. But if you watch the cloud shadow, it may be just expanding in all directions. And you might not see that just by looking up. You might just see this edge of the cloud coming out here. But if you got a picture of the whole shadow, you can see the whole thing expand. It's kind of fun. So, all right, let's go forward a little bit. Let's see. We're looking at, now we're looking at the beginning of next week. Let's take a look at Sunday. I want to see what's happening on Sunday. All right. What's that? What was that? Right, exactly. Are we going to have a window on Sunday? Because you look at the big forecast and it's like, if you're looking at like the TV weather, they're like, it's going to be rain, 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 rain. Sundays, partially sunny, and then rain, 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 rain. Like, okay, maybe Sunday. So let's hone in on Sunday. according to this, at 12 o'clock, so again, GFS 700 millibar. What does that equate to feet-wise?
10,000.
Yes, top of the Wasatch-ish. Okay, and it changes, the millibar pressure level changes by 200 to 400 feet maybe, so we just use an approximate 10,000. All right, so we've got decent winds, 5 to 10 knots. At noon, let's see what happens at the next click. It is a 6-hour forecast. So it doesn't look like we have many problems with the winds according to this model. So we can check other models and then we can hone in on the area, but that's just super quick first glance. All right, let's get out of this page. So learn to use tropical tidbits, learn to use windy, learn a couple of these things and delve into them, and the more super nerdy you are about it, the more you learn. And pick the brains of your friends. And it's fun stuff. I think it's pretty addictive. All right, so that's kind of looking at the big picture. Now, how many of you have heard of XC-Skies or use XC-Skies? Okay, awesome, yay. If you haven't, it's a great resource. It has its own tutorials, so it's really fun to jump in and click around and use those tutorials. And if you are delving into it and you have any questions, I have, it's like a 2-hour long, it's ridiculously long, but it's a YouTube, kind of YouTube tutorial about how I use XC-Skies for local flying. But the very simplistic look at XC-Skies, we'll go to that link. You do have to have a username, password. I think it's like a paltry $5 a month, and it's been that for as long as it's been in existence, like 15 years. So,
I think we lost you.
No. Darn.
though I'll talk about XC-Skies when they're working on it. So it was created by Chris Galley, who's up at the University of Utah, research professor up there. And I think he had a couple people with a hand in it, in its creation. But it was getting going, I think, when I was a student at the U, so about 15 years ago. And it's evolved over the years. Chris is an amazing pilot. He's a Utah Cup winner. I think he still has the state record.
State PG record?
Yeah, for paragliders.
Yeah,
Yeah,
record.
PG record, yeah. On a very windy day from Jupiter to the north.
25 mile an hour at top of lift.
Yep, that's a strong one. But anyway, so he knows his stuff. Super nice guy, good pilot, appreciates input. And again, the good tutorials on his site. So he created this for soaring pilots. So it has more of our sync rate as opposed to the soaring forecast, which is more designed for a sailplane sync rate. So it starts out with this menu here, and it seems like a lot. I think if you scroll over these, it gives so again, it's kind of like the dictionary. It gives you a little definition of what's up there. So is there a way to show this and I should have had a sheet of paper with it.
Yes.
Oh, what, are we nervous?
Let's see. I'm sure I can pull it off.
Actually, just flip back to the other one once, and then
This one?
my notes, and then I'll take it from there. Okay, so I'm just a super quick look at XC-Skies for the area that we want to fly, and this includes the point. Is you can look at the different models if you're looking at it in advance. It only has the GFS, it doesn't have the EC. So the GFS is for multiple days out, like 2, 3, 4 days out, I think it goes, so long range. If you're flying today or tomorrow, the shorter range ones, the NAM 3K means its resolution is at 3 kilometers. I think the GFS is, the one in our office is 13 kilometers. Do you know what Chris's is?
12 to 13.
Yeah, so it takes squares that are 12 by 12 kilometers, and it assesses the weather over that square. So it's a little larger model area. The NAM 3K does 3 kilometers, and then the HER does 1 kilometer. And those two are updated more often as well. And so if you're a day or two out, those models are good to go to. So the first thing I look at is winds. And the 12K wind is something that it really interests me. Long ago, Bill Belcourt had a kind of a rule of thumb about 12 knots, 12 at 12 miles an hour at 12,000 feet. If it was stronger than that, it was maybe a no-go. I'm sure he's expanded it, but it's kind of a good rule of thumb for how intense the flying can get. Stronger winds can shear thermals, things can get bumpy and gnarly. So I don't like to fly if I see 15 knots at 12,000 feet because I want to be able to go up higher. And if you're going up higher and it's already 15 knots at 12, it's generally going to get stronger. So 12 at 12 is a good general rule of thumb. So I look at the winds at that level, then I'll go to the surface, and I'll go up to the top of the lift. So I'll try to peruse the whole layer. And then after that, I'll look for overdevelopment. That's a real big issue. This is what we've been having for the last 3 weeks. So it's when you get heat, you get moisture, and you get a source of instability, you will get thunderstorms. Now these are produced more from a low. In the summer, you get more of a monsoonal pattern where it's a larger pressure system and it just sits there and sucks up moisture from Baja and the ocean, and it just comes in every day and it doesn't blow up until you get the heat. So it's kind of a similar pattern to the monsoonal, but it's not the monsoon yet. So anyway, so OD is, overdevelopment is a big issue. So winds and OD are the primary things I look at. And the two components I like to look at are CAPE, which is convective available potential energy. It's the amount of juiciness in the atmosphere. And it's measured in joules per kilogram. I like to keep that number under 300. Keep it low, and then if your cloud depth gets really big, then you know you're going to be flying in clouds. And then the lifted index is like, those are the 3 parameters. So we're going to take a look at an example on Uhgpga'S. And again, this might be a little heady for some people if you haven't delved into Uhgpga'S, but just start playing with it. Just start out looking at winds. Look at the parameters that you understand. Check out the tutorials on there. They're really good. And then when you're ready for maybe a drinking game, every time I say OD, you can take a shot or something. So listen to the YouTube. Okay, so first thing is you can set up your own forecasts for the place and the time that you want to fly and the model that you want to use. So let's go to, can we see the whole screen? Okay, never mind. Let's go to, okay, so we want to fly, what's today's Thursday? We want to look at Sunday, so we're going to have to go big model GFS. Let's look at Sunday, and our offset is -6, so we're set for Utah time. So let's go at noon on Sunday.
Oh, that's Saturday.
Okay, and then, yeah, scroll out. Okay, so you can get the whole world when you scroll out. Chris is just evolving this for other countries besides the US, and he used it for the Xpier in Spain when was that? I guess last fall, and it worked pretty well. Okay, so let's look at the point area. Yep. So we've got here Draper and Lehigh, so we've got the point area on here. And then, so like I said, let's go to the 12K winds. Can you bring up here it is. Click on the surface and pull that down.
Oh, right.
That one, yep. Go to 12,000. All right, and so those numbers are mean sea level, so 12,000 MSL, which is, basically 8,000 feet above the surface, 7,000 feet at the point. Okay, so we're looking at, okay, we've already.
Day to fly from Innsbruck to Point.
It's a perfect day, yes. And we've got 10 knots down here, little spicier as we go north, and then some 20-knot winds. This is at 12,000 feet, so it's a lot of areas are already surpassing our 12 at 12. So we have a general idea of, okay, it's pretty windy up there. Maybe a little less windy in the south. Maybe Camels might be good, or Inspo or something. All right, so now let's go down to surface on the winds. Okay, so surface winds are pretty light. They are all over the place. What's going on? We might have, it's just the beginning of the day, it's heating up. if we see, so the barbs are here, that means the wind is coming in here. Barbs are here, the wind is coming in here. Those winds are converging. So that's your first indication we might have a little bit of convergence happening, although this is at the surface. So it's light winds. That's kind of our general message. Let's go to top of lift winds. Yeah. So top of usable lift gives us both our, let's see, I think surface we have to go to top of winds as well.
Oh.
Top of the lift, there it is. Yeah, so these are our winds at the top of the lift, and this tells us what that top of the usable lift is. Here's the legend over here. Your eyes will get used to it quickly. Numbers in like greens and yellows are maybe 4,000 or 5,000 feet above the surface. And then the juicy numbers, you go into the reds, and when you get up to the yellows, then you're getting close to that 18,000 foot. So you can start looking at a glance. The tallest top of the lift is out in the Uintas, and this is only at noon. So big sink over the lake, of course. You don't want to fly over the lake, or the Great Salt Lake. And then, okay, so far it looks good. Top of lift winds are a little bit stronger to the north, a little bit less in the south. Let's move forward in hours. What will it let us jump to? It goes hourly, good. Okay, so we can just jump forward now and see how the day progresses. Okay, it stays a little bit more windy to the north, stays a little less windy down south. Looks like a good line. Oh, I'm seeing 4 o'clock. That lift that was in the 16, 17,000 is now very low. What's going on here? That's an indication that you're going to probably have some clouds and maybe some showers, maybe some thunderstorms in that area. So that gives you your first clue. Well, you had really good lift, and by 4 o'clock in the afternoon, it's gone. And it's still good here, but now let's go to the OD factor. We've gone through our winds, so let's go OD. Let's look at the lifted index. So this is another good indication. In a nutshell, if you raise a parcel up in the atmosphere and you have the actual atmosphere's temperature, if the parcel at, let's say, 18,000 feet is warmer than your actual temperature, what's going to happen to the parcel? It's still going to keep rising. So that's a level of instability. That means your parcel and that's an algorithm that's created from the observations from the morning sounding, but it's telling you what an idealized parcel would do. It's going to keep going up. So when the temperature difference reaches 3 degrees in difference, this is 3 degrees warmer, that's the top of your -3 that we looked at from the soaring forecast. So if that's way up here, when the numbers get to be the same, what happens to the parcel? It stops rising. Does it sink? Not yet. When the number starts to cool off, cooling air sinks, rising air or warming air rises. So the lifted index, you want just a little warmer parcel. So that's going to be 1 degree difference. So when you're subtracting, it's a -1. So the juicy number for good lift is in the yellow there. Did they change their colors?
I think
No,
it's still
that's
red.
it. Yeah. So that yellow is the -1. So that's a really nice instability point to be at. If you get more unstable, -2, -3, that's definitely, from that parameter, that's an indicator that you might have thunderstorms. So that seems to be the same place that we saw that green, is where you've got your -2. The other numbers, as you get more stable, the light green, that's okay. You know, it's starting to get more and more stable. The areas of blue, obviously, like over the lakes, you know, pretty stable. So if I see those lifted indexes become more negative than -1, that's an indicator we might have some thunderstorms.
That's different than the -3 index.
No, those are different numbers. The -3 is where the lift slows down. That's more of a thermal index. but this is a lifted index. So I wouldn't confuse those two. You want to see on the lifted index here, you want to see a -1. You don't want to go more minus. I mean, this is along with the other parameters too. So the other one we're going to look at is CAPE. So the amount of juiciness in the atmosphere. You want it 0 or maybe 300. And these blues are pretty close together, so it's not very helpful for people that are colorblind, but there might be a way to like get a number value too.
I think you can adjust it like if you wanted to.
Oh, look at that.
You can click on points as well, and it'll tell you.
Okay, cool. Look at that. Excellent. So for what we have here, we're obviously, the darker stuff is showing up. So the area over Heber City has a little more CAPE. Actually, that has less CAPE than the surrounding area. Yeah, that has the 0 CAPE for some reason. Let's back off the time and see how the CAPE evolves from noon. Okay, so there's a lot of potential for juiciness, but as you see, it's just drying out. It's getting less and less CAPE as the day goes on. So that's one indicator that your afternoon may be drying out. So let's do the same thing with lifted index.
Start at noon.
Mm-hmm. Okay, we got our yellows along the Wasatch Front. We got some oranges popping up. Okay. So that's telling me that there's probably going to be some isolated areas along those mountains. So see, I'm just working with the colors, comparing them to CAPE, and then what we had before with the top of the lift. So it's kind of a conglomeration of different aspects, and the more you look at it, the more you'll see. And a really good thing to do is look at it and then assess the day. What did you look at, and what was the day like? And then remember that this is just the GFS. This is 3 days out. So as you get closer, you can do this with the HER and the NAM3 to get more honed in on it. Okay, that's enough of XCs, guys. Any quick questions on that?
What does CAPE stand for?
Convective available potential energy. It's the juiciness. It's how much could erupt in the atmosphere given its instability and moisture. Like the CAPE in Florida is like 1,000 joules per kilogram. But I've seen, King Mountain blow up with 250 joules. So good number to be aware of. Okay, and then that's pretty much it. And then windy, like I said, explore windy, see the different parameters. It's kind of, it's a one-stop shop for a lot of things. Do they have lifted index on windy?
I'm not sure about windy.
Okay, I don't think, does anybody know? I don't think they have lifted index on windy.
Looking at it yesterday, I'm pretty sure they don't.
Okay, yeah, so it's, use the right model for what you want. Thunderstorm chances, this is a good link. It's not super accurate, but it'll give you kind of a probability. So if you know there's 20 or 30 in the area versus 0, that's kind of a big deal. So we'll want to go to, and I explain this in the sheet, the top red tab. Click on that, and the first one down is calibrated thunderstorm, 3-hour calibrated thunderstorm. And then look at your time. We've got, let's go back. You can use no, that's speed. The step is in the upper right-hand corner.
Oh, I see.
Yeah, let's go backwards because this is where the model run stopped. Okay, so let's do our Sunday. Yeah, so go to 12. All right, so Sunday morning at 2 more clicks.
Still back.
Forward.
Forward, okay.
Sorry. There it is. So Sunday morning at 6 a.m. Beautiful. Okay, we don't expect to see a lot of thunderstorm chances unless there's like a front coming through. But as far as afternoon convective stuff, there's not a lot of heating or mixing yet. So, all right, let's go step forward one. Now we're at 9 a.m. One more. Now we're at noon. Okay, maybe a little of activity over the wind is starting at noon. Move on to 3. Oh, we got a lot of stuff happening at 3 o'clock. So looks like over There's 10%, it's not much, but in the back of your mind, that's okay. There could be some isolated here and there. And then the UINAs are 20%, so you don't want to take that chance over the UINAs. And then let's see, one more. And so it doesn't look like a lot's happening as far as 5 or 10%, but the UINAs is probably going to go off. So if you're hiking up in the UINAs, a 30% chance is pretty good for an isolated shower. So that's just something to look at. Again, 5 or 10 is not much. You start getting up to 20 or 30 or more, then there's a good chance you'll have something, especially if you're planning a long route. But 0 is really nice. So, you know, there's still a chance, of course. This is just a forecast. It's just a model. But I think that's a useful page. I've gotten some use out of it. Okay, back to the script, and I think we're almost done. And then there's the SKU-T for people that want to get really into it and advanced. There's a good tutorial on the SKU-T. You can just click on that link. And I won't go into that now. And then, of course, you've got the, one more click down, the National Weather Service Forecast Office in Salt Lake City. It's located at the southeast corner of the airport. You guys are welcome to come up anytime, take a little tour, get to know some of the forecasters in there. All the discussions have our last names at the bottom, so you can see who's writing what, who uses fancy language. I always try to make my discussions geared toward pilots. So, yeah, and that's pretty much it. And then we've got like 20 minutes, half hour for questions, if anybody would like to speak up. Yes?
Will you repeat the questions back?
Yes, I will, if I can hear them. Okay. Okay, let's start.
Just bring the mic around.
Oh, perfect. Okay.
Where's the info? Is it right here?
Was that helpful? Was that useful? Was that too much? Okay, cool. I wasn't looking for that, but I'm glad. I'm really glad because.
Over and over for the next couple days.
Okay, yeah. Oh, and if you find a driver, you can just pick my brain for the whole time I'm driving with you, or if you do drive.
That pays off.
Joey.
What's the fastest way to calibrate your numbers for a new region? So let's say you're traveling to Australia and you want to calibrate your OD numbers. What's the fastest way to do it?
Talk to a local.
All right.
Yep. The locals, the models can spit numbers out through their ears, but the locals know best. So anytime you go to a new site, hook up with the locals, ask them, sit down with their models that they use, especially in Europe. The Medio Blue stuff, they have some great models over in Europe. And so I would say the number one thing is hook up with locals. Sometimes you go to places like Colombia where nobody looks at forecasts. And you just delve in, you look at XC skies, and you compare what you get that day with the forecast. Especially when you have different forecasts that are all coming together and giving you the same solutions, that's a pretty weighty forecast. That's good. And then if your conditions were like totally different, then maybe you can't use that product, or you start calibrating by experience if you don't have the local pilots. But I would definitely check with them first. Yes?
Where will this document be available for us with all of these?
We'll get this up on the website.
At the
We will
website,
have
on the
this. The
website?
question was, where will this be available? Heather will do her magic, and Neil, and whoever will get it up on the website.
A great resource, that'd be awesome.
Oh, good. All right, thank you. Yeah, awesome.
I think we might put a little Lisa's Corner in the weather section so that you can go right to
Yes.
your stuff.
Then you can ask me questions like, this guy I'm dating wants to go paragliding, but I don't know, should I go? Yeah.
Well, the answer always yes. Weather dependent.
Yeah, it's weather dependent. And if he'll give you free tandems. Okay, other questions? Yes?
The forecast, the weather service forecast that comes out in the morning, this soaring forecast.
Yes.
That has the -3. Is that based on the balloon readings? And so that's the current -3. Does that,
Yes.
how much does that change once you're getting like 8 hours later?
That's an excellent question. Different models are designed to extrapolate, because all that is an extrapolation of an ideal parcel versus the real temperature. So if you look at a SKU-T, sometimes it gives it at the current time, but usually it will give information for when the temperature, when the atmosphere is mixing out. So when it starts heating up. And there's a line called the adiabatic line. And so the model will assume that it's going to follow this line when it mixes out 10, 11, noon, gets to its hottest part, and it will extrapolate the information from the middle of the afternoon. So I'm not exactly sure what the algorithm does, but I always take it as this is what's going to happen this afternoon. So I don't take it as a morning one.
So like the one where we saw it said like 8100 was
Yep.
-3. Does that mean like, oh, once we get Soren, it'll be 8100, or like could that lift to 10 or 12?
Well, you saw the top of the lift was 18.
Yeah.
So what that tells me is you're going to launch inspo, and you're probably going to find some thermals, 1, 2 o'clock in the afternoon, but you're probably going to they're going to slow down at 2,000, 2,500 above. And if you're going to get up above that, you're going to need a strong thermal. And that's when you look for clouds, you look for things that are developing, because again, all of this stuff is, number one, it's idealized, and number two, it's on a large scale. But we fly gullies. I mean, we fly things that are so micro small that you have to think a lot smaller, and a lot of stuff could happen within the forecasted area. So 8100 is just like the two pieces of information I get from that 8100 versus the top of the lift at 18,000 is that you're going to have a capping layer. If you look at the SKU-T, you can often see that. You're going to have a capping layer, you're going to need something strong to pop through it. But if you do pop through it and you can be patient, maybe later in the afternoon, you could get up to 18. It's possible.